चॉइस करके, मल्टीपल चॉइस ही रहने दो, मल्टीपल चॉइस, और बस ऑप्शन 1 ही रखो बस, इसको delete करो, इसमें लिख दो स्कूल ऑफ इंजीनियरिंग, बच्चे इसी को सेलेक्ट कर लेंगे और भी ऑप्शन रखेंगे।
मेंटर्स नेम में भी हम अपने अपने सब फैकल्टी के नाम ना दे
वो
दें।
कर सकते हैं, पर वो है कि पहले पूरा बन जाए ना, ये चीज के बाद कर देंगे, ये क्यों करके ही ना,
हाँ फिर वो नहीं होगा।
बट ये पहले ये बस नहीं 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 नहीं, तो
ये तो अपने आप ही सबके लिए आंसर यही ले ले, बस खत्म।
मतलब ये तो बस इसलिए कर रहे हैं कि बाद में रिपोर्ट बने ना,
हाँ।
तो हमें मैन्युअली
अब ऐड
करना पड़े।
चलिए,
ऐड करो,
डिपार्टमेंट स्कोर पता,
रिपोर्ट का
सिविल
सैंपल,
इंजीनियरिंग वही हो।
रिपोर्ट के सैंपल में क्या है, इन्होंने रिपोर्ट का सैंपल भेजा है ना एक, उसमें क्या लिखा है वो देख लेते हैं। तो उसमें स्कूल का ही नाम है, तो ठीक है बस स्कूल ही रहने दो।
डिपार्टमेंट,
हाँ डिपार्टमेंट को चेंज करके स्कूल ही
ये
वही है, उसी पे क्लिक करो ना,
हाँ
ऐसे ऐसे,
हाँ
नहीं नहीं ऐसे नॉर्मल क्लिक करो, अभी नेट नहीं चल रहा है इसलिए गड़बड़ हो रही है।
हाँ।
आप देखो अभी शायद
मेरा
हट रहा है,
फोन से चल रहा
देखो ना ऊपर लिख रहा है रिकनेक्टिंग।
है, मेरा फोन से तो चल
हाँ बस
रहा
अब आप तो सेंड करते हो, हाँ आप कर दो,
है।
स्कूल लिखो बस।
Hello? Hello from organizing team. Someone is there?
I am there, ma'am.
Okay. Then Gaurav sir join.
No, I'm not able to see, sir. That's what I'm checking.
Yeah, then we have to call.
Okay.
Just call, give a call because now time.
It's 157.
Just inform you want to check also.
Okay, I'll call him.
Mm. Till Gaurav sir is joining, anyone in out of 28 people are from outside any other college? Anybody want to give the feedback or anything? Then you
Ma'am,
can.
Gaurav sir will be joining in another 5 minutes, it seems.
Okay, so till 5 minutes, I am talking to the participant who are here. So I'm requesting any participant who are from outside college, outside our Oxford college, can unmute yourself and you can talk. Vijaya Durga. She is from outside college. Jarad sir. Vijaya Durga. One name I have observed. Anyone want to give any suggestion or anything they can give because now 5 minute time is there. Write in a group also, Jarad sir. Only 31 people join.
Yeah, ma'am, I'm writing.
Mm.
I'm putting in WhatsApp.
And write that same link they have to join.
Hmm. Hello, Preeta ma'am.
Yeah.
Ma'am, Sarah's joined.
Okay. Gaurav sir.
Yes, madam. Am I audible?
You are audible. Okay. Your video is not.
Yeah, actually there is some issue. That's why I joined through my personal computer.
Okay. Okay. So sir, we will start, and in the meanwhile,
Mhm.
people will join because
Okay,
today is Ram Navami. So north side, all the colleges they have given leave. North India.
Yes, yes. Yeah,
So
yeah.
people
Okay.
in south we are working today, but in north
Okay, okay.
actually all the colleges today is leave. But then also morning this one was good. Yes, Jairaj, morning
Yeah, strength was good.
strength was good. So we'll see. People will may join. Okay. So formal way we will start now. Gaurav sir.
Yes, madam.
Yes, yes. Your photo is also now visible.
Yeah, yes.
Okay. Good. Very nice. So you are giving talk in quantum.
No, ma'am. On in all optical technologies.
Okay. Okay. So 1 hour you can give.
Yeah,
If
yeah.
you want
Okay.
little bit, you can extend. That's up to you.
Okay, okay.
Okay.
Okay, okay. Okay.
Okay. And Jara sir, you have written now. A participant should join now.
I have put it. I put it in the
You put.
WhatsApp.
Okay. Now you can start, Jara sir.
Good afternoon to one and all present here. On behalf of the President of Children's Education Society and Chairman of the Oxford Educational Institutions, Management, Principal, Deans, HODs, staff and students of the Oxford College of Engineering, I, Jayarajan, Assistant Professor ECE, welcome you all to the afternoon session of third day of 2 weeks International Faculty Development Program on Advancement in Quantum Computing and Sensor Technology for Vikshit Bharat at 2047. It is my privilege to introduce today's speaker, Dr. Gaurav Kumar Bharti, an eminent speaker from IIIT Bhopal, who is going to deliver a talk on fundamentals of nonlinear optics and optical switching. Dr. Gaurav Kumar Bharti obtained his PhD in Electronics and Instrumentation Engineering from NIT Agartala, Tripura in the year 2020 and postdoctoral fellowship from IIIT Guwahati in 2021. He has a vast teaching experience. Dr. Gaurav's areas of research include cyber-physical systems, quantum computing, nanophotonics, electromagnetics, optoelectronics, instrumentation, photonics, optical sensors, nonlinear optics, modeling and simulation. He has 25 plus journal publications in SAS corpus and 20 plus conference publications in Web of Science corpus. He has various books and book chapters authorship to his credit. Dr. Gaurav Kumar Bharti has patents and sponsored projects funded by MP Council of Science and Technology Bhopal, Department of Science and Technology, Government of India, and sponsored consultancy projects. He has 50 plus projects supervised under UG level, 2 PG dissertations, and 2 PhD theses supervised. Sir has held various responsibilities in academic as well as research. To name a few, he is a coordinator of Internal Smart India Hackathon 2023 for IIIT Bhopal, founder branch counselor of IEEE Bhopal student branch, received fellowship for visiting faculty at IIIT Tech Turkey under IFFP CU. He was a member of Departmental Research Committee of EED Chandigarh University. Dr. Gaurav Kumar Bharati received Best Chapter Advisor Award of IEEE Photonics Society CUSB for the year 22-23. Transformative Researcher of the Department Award for the year 2022 by Chandigarh University. His biography is included in Asia Pacific Who is Who Volume 17 by Rifacimento 11 International India. He has visited a number of countries including Thailand, Turkey. His professional memberships include IEEE Photonics Society, IEEE Sensor Council, IEEE Young Professional, IEEE Nanotechnology Council, Optica, SPIE, and IE. On behalf of the Chairman, Children's Education Society, the Principal, Faculty, and students, the Oxford College of Engineering, I extend a warm welcome to you, sir. Now I request you to take over the session.
Thank you very much, Dr. Jay. So I'm going to share my screen to start my talk. Am I audible to everyone?
Yes, sir, you are audible.
Oh, okay. Yeah. So for today, I will discuss about the all optical technologies. So all optical technologies basically the technology which deals with the optics. Optics means light. You can say just not light. It is like a manipulation of the light. Photonics is the manipulation of the light to just do the engineering with the ray of lights like for polarization, for switching, for sensing technologies, even for quantum also. So uh, a little bit I will discuss about the silicon photonics, then photonic integrated circuit, ring resonator, and some ring resonator based optical sensors. So if you will see the photonics and its application, the photonics basically we can divide in number of applications like for the in terms of material and material science engineering, people are working on the silicon materials and optical materials, you can say, and doing the engineering in such a way so that it can give some uh, better result for different applications like photo detector, sensors, and all. Second thing is the architecture, or you can say the structure. So recently we have seen in the research field that the research group in India as well as abroad going to is very much interested to design some novel architectures related to photonic crystals, waveguides, and gratings. So the third thing that you all can see if you are the active researcher of the photonics, that there is some ongoing researches everywhere in India as well as in abroad, that light matter interaction based like sulfur plasmon resonance SPR sensor, metamaterial based sensor, and all. So these are the also the new area of research. Okay, so the fourth point is the optoelectronics. So this is the traditional area where people are designing photo detectors and all, and they also nowadays some groups of India are working on the neuromorphic computing as well. Then energy solar cells based on the graphene or non-graphene based like flexible solar cells. Then for optical communication, we can see the light sources, different transmission medias, and all. So photonics is of great importance. Recently, United Nations has declared International Day of Light as 16th May for each year. So as you know, the 21st century is depend on photonics, and as like as the 20th century dependent on the electronics. So you all know the optics is the branch of physics which involves the behavior and the properties of the light, including its interaction with matter and construction of instruments that use or detect it. While the photonics is the area or the area of engineering where we can do the manipulation of the light sources, adjusting its light to using polarization and all, utilizing all the properties of the lights except you can say the reflection, refraction, and absorption. So for the present demand, we need the high traditional speed. So for high operational speed, we need to replace electron by photons because photon will not suffer the problem of electromagnetic coupling as well as the interference. So due to high ever increased demand of communication and data transfer, we need not only require the network, but an all optical network is more preferable. Then optical to electrical and electrical to optical interfaces also cannot operate few above tens of gigabits. So therefore, there is a demand of all optical communication. In all optical communication, the input is in optical domain, output is in optical domain, and the processing itself is in optical domain. But in optoelectronics, input is in optical domain and output is in optical domain, but the processing is in electronic circuit. So this is the disadvantage because electronics having the charge and mass, but photons having no charge and no mass. So we can divide broadly the photonics or its component like this: generation, control, transmission, processing, and display. Generation, we can generate the light sources using LEDs or lasers. Control, we can control the light using optical switches, filters. We can transfer the light to using optical devices using the waveguides, optical fibers. Processing, we can process the light by employing the you can say the principles of optical communications. Then for display purpose, we can use the OSA, optical spectrum analyzer, optical oscilloscope and all. So we can see photonics everywhere in rainbow optical communication. In nature, we can see the sun, and in culture, we can see the colorful drawing. So photonics basically deals with some dynamic effects like thermo-optic effect, electro-optic, acousto-optic effect, magneto-optic, electronic linear effect. So for thermo-optic, so when we will give the heat to any of the material, then there is a change in the reflection, or there is a change in the transmission of the output of the that switch or that material. Then this phenomena is called thermo-optic effect. Similarly, for electro-optic effect, we can see the change in the transmission of the output. So basically, you can define that this phenomena is called electro-optic. Similarly, due to sound and due to magneto, due to optoelectronic, there is a same type of phenomena. Now the pacing device. So, pacing device like optical power dividers, polarizers, multiplexer, demultiplexers, gratings, or we can say photonic integrated circuit. So for this, suppose in this circuit, there is a ring resonator, okay, and there is one laser source, and this optical ring resonator, the source and the detector is in the same platform, have, then it is called the hybrid element. Okay, now the polarizer. So you all are familiar with the polarizer. Suppose if you are giving a randomly polarized light to the polarizer, linear polarizer, then it will rotate the angle of the polarization in such a way that the linearly polarized light will propagate. So optical and all optical switching.
नहीं डिवाइसेस का इशू होती है
Yes.
सॉरी ये पुरानी डिवाइस हो सकता है कुछ मेरे ये वाला नहीं कर रहा ना
I request all the
Hello.
participants to kindly mute yourself.
नहीं कह सकते क्या है चल रहा है लेकिन
Yeah. So all optical versus all optical. So we can see.
1 second,
Yeah.
1 second. Actually, organizer, please, you see that whoever is not muted, either you mute, if not possible, then remove them from the meeting. Okay. Okay, continue, sir.
Okay. So there are two types of switching in optics. First is the opto-electro-optical switch, and the second one is the all-optical switch. In opto-electro-optical switch, this output and input are in optical domain, but the processing is in electronics domain. So this is a disadvantage because we need to change optics to electronics and electronics to optics circuitry by using some circuitry. So this is the drawback. So that's why nowadays researchers are working on all optical switching, where the input, output, as well as processing is in all optical domain. So suppose let us see this example. There is no input and control signal. You are not getting any output from any of the port. But when you are giving the input signal from here and no control signal is there, then you will get the output at output port 2. But when you are giving only control signal, no output you will receive. But if you will give the input and control signal, there is a change in the output port, which the output you are getting at output 2, now you are getting at output port 1 due to this control pulse. So this control pulse is the main thing behind it, so that you can so that you can change the output of the device due to this control pulse. When the control pulse is 0, you are getting the output from output port 2. When you are giving the control pulse, then you will get the output from output port 1. So for silicon photonics, Richard Soref is known as the father of the silicon photonics. Silicon is the centrosymmetric crystal having the size of 1/6 of its wavelength, whatever the wavelength you are giving as an input. So it basically operates in the infrared region, where various non-linear phenomena will occur, like optical Kerr effect, two-photon absorption effect, Raman effect, and all. So the main thing is that for silicon, we need to remember the Kerr coefficient and the TPA coefficient, because by changing these values, you can change the switching performance of the silicon material, because due to this, you can easily control the refractive index of the material. The third point is that the silicon and SiO2 having the high refractive index contrast. So therefore, there is a unique light guiding property and modes are tightly confined in it. Also, the next point is that it is a thermally stable and it is possible to create hybrid device where electronics and optics are in a single chip. So, as I already explained here, that there are two phenomena, Kerr effect and two photon absorption effect. So, for two photon absorption, the refractive index is changed by the carrier concentration under the applied electric field. Whenever you are giving some high intensity of light, the refractive index of the material gets changed. So, it means that there is a change in the concentration of the electron and holes. So this change in concentration of the electrons and holes will change the refractive index of the material, and this is the responsible for the switching of the silicon material. So if there is a change in the real part of the refractive index, then it is called electrorefraction, and when there is a change in the imaginary part of the refractive index, then it is called electroabsorption. So this formula is the best empirical formula stabilized by the Graham Reed in nearly 2010, that change in the refractive index of the silicon material at 1.55 micrometer, or you can say 1550 nanometer, is given by this formula. According to this formula, delta Ne is the change in the concentration of the electron and delta Nh is the change in the concentration of the hole. And since the electron and holes are same, so that's why you can write delta Ne is equal to delta Nh is equal to delta N. And you can calculate the change in the refractive index of the silicon material whenever you are giving the high intensity light or the high voltage, whatever you will give. Okay, so the concluding thing is that you can easily change the refractive index, manipulate the refractive index of the silicon material. And why we need to do this? Because the silicon photonics market is projected to grow from USD 1 billion to USD 3 billion by 2025. So there is enormous scope and unlimited opportunities, wide application areas. But very few groups in India are actively involved in silicon photonics research. So we need to explore more and more in the silicon domain. So the photonic integrated circuit, like electronic integrated circuit, there is photonic integrated circuit. So for photonic integrated circuit, you can say there are two varieties, like all optical, and another one is the optoelectronic, that is the electrical optical and the optical optical, like this. So you can design based on its working. Similar concept you can use for electronics for routing the signals, because in electronics you are routing the electrical signals, but in photonic circuits you are routing the light signal. So the what is the advantages? The advantage is that multi-floor architecture, that electronic integrated circuit can be replaced by a single optical waveguide layer. It means it is highly compact. Hybrid multiplexing can be done easily, high bandwidth. And but if the disadvantage is that when you are using it as a optoelectronics, or you can say opto-electro-optical switch, you need to use some converters. So this is the disadvantage. Another one is that silicon is somehow costly compared to another group 3 4 materials. So and the size is comparatively large in um, dimension. So you can see here um, this point that in 1971 we are increasing our technology from platinum, from you can say for data transfer, for optical routing, for data centers. So from 440 platinum ICs that we are using by Moore's law, we are increasing day by day by using silicon photonics. So by using this, you can design an n number of circuits, or you can design a complex optical router in by replacing you can replace complex electronic router with optical router. So another point is the laser sources. So these are the just highest power that we are getting through the laser. So the next point is that if you will see in terms of complexity, in 1994, starting from the 1994, there is passive integration. Then 2004, the new technology called optoelectronics come into the picture, and then silicon photonics from 2010 by introducing by Robert Baird and all his team, and then from 2014 to 2024 till this year we are working on optical circuits. Now what is the next area? So the next area is the quantum circuits. So we need to explore more by using the advantage of the light. We can explore the quantum circuit. We can design the quantum circuits. So the next point is the polarization. So polarization is an important role in photonics because it will give a chance, it will give some possibilities that you can control the electric field vector. So at low intensities, the electric polarization is proportional to the electric field strength, but at high intensities, you can see the nonlinear contribution become important. So that's why it is called nonlinear. So when you will see there is a low field
Sir, that film
intensity.
nice, sir. You see, Manjimal
So,
Boys. That film nice. I saw
so
Manjimal
D
Boys.
is
I saw.
electric dipole moment. D is the epsilon naught E plus P. So whenever you are giving the high intensity light to any of the material, then you will see there is electric dipole moment. D is given by epsilon naught E plus P. So E is the electric field vector and P is the polarization. And you know all that P is the epsilon naught chi E. Okay. So when you will rewrite this, then you will find that P is directly proportional to E. It means D is also directly proportional to E. So it means that whatever the electric field you are giving, you are observing the same proportional value of the electric field vector displacement. Now for nonlinear medium for high intensity, when there is high intensity, then the formula is same for electric dipole moment. D is equal to epsilon naught E plus P, but the polarization is given by P epsilon naught into chi E plus chi square E square plus chi Q EQ. So this chi is responsible for the nonlinearity in the material. So for silicon, there is second order nonlinearity, and the third this third order linearity, and for second order there is second order nonlinear susceptibility tensor. So if you will see the third order nonlinearity which having silicon having third order nonlinearity because it is centrosymmetric crystal. So there are two phenomena as I told you in my previous slide, that there is some two effects called Kerr effect or two photon absorption effect. So Kerr effect is just a modification of the refractive index due to high intensity light, which leads to the phenomena called self phase modulation, cross phase modulation, Kerr lensing, and four-way mixing. So if you will see the overall in a if I will summarize it, then you can see the nonlinear optical effects. There are two types basically, because single order nonlinear effect is same as linear nonlinear effect. So second order, third order is of much importance. So second order nonlinear effect is due to non-centrosymmetric crystal, and due to this you can observe the Pockels effect, electro-optic effect, second harmonic generation, sum of and frequency generation, difference of frequency generation, and optical parameter amplification. The third order nonlinearity you will see in the form of optical Kerr effect, third harmonic generation, four-way mixing, two photon absorption, stimulated Raman scattering, cross phase, and self phase modulation. So for silicon, which is having third order nonlinear effect, having centrosymmetric crystal, which is like this. So there I will describe you the two photon absorption. So for two photon absorption, you will see due to this, a real part leads to self phase modulation, cross phase modulation, and four-way mixing, while imaginary parts leads to the two photon absorption. Now another point is that how two photon absorption will occur. As you know, so direct band gap of silicon having the direct band gap of 3.4 electron volt and indirect band gap of 1.2 electron volt. So if you will give the high pump power to the material, okay, high pump power to the material, so it is sufficient enough to go from the lower energy level to higher energy level when if you will apply the sum of the energy of the two photons. But when you will give the energy of one photon, it is unable to go from the lower energy level to higher energy level. So that's why it is called two photon absorption, not one photon absorption. So two photons are required to be absorbed in silicon so that the charge carriers will go from lower energy level to higher energy level. So the suitable repetition rate of the pump pulses is required so that the free carriers can recombine. Or if there is some losses, you need to do pulse pumping or large reverse bias is necessary to apply to decrease the carrier lifetime. So ring resonator, if you will see, there are two configurations, circular as well as racetrack. For circular ring resonator, there are two varieties. First is the single waveguide coupled, and the second one is the two waveguide coupled ring resonator. Similarly, for racetrack ring resonator, single waveguide coupled ring resonator and two waveguide coupled ring resonator. For silicon ring resonator, or you can say the simple ring resonator made up of any material, there are three concepts. First is the constructive interference, and the second one is the total internal reflection, and the third one is the optical coupling. So whenever light will go from the input port, so due to constructive interference, most of the light will couple into this coupling region and go to this ring area, and it will make a round trip, and after some time it will get out from this output port. So this depends on the constructive interference. And the second property that I have written here, that total internal reflection, it means light will propagate only inside the waveguide. And the optical coupling is this: when there is a circular waveguide and if you will put a straight waveguide in its proximity, then some of the light will go to the circular waveguide as well. So this is called optical coupling or evanescent coupling. So advantages of the ring resonator based on the all optical system. Uh, it is small, having less complex narrow band, large phase spectrum range, high wavelength selectivity, ease of cascadability and all. So there are various advantages in terms of another photonic devices. Yes. So whenever the light will, you will give the light through the laser source, most of the light will couple and it make multiple round trip. So which light will couple and which not, it depends on the formula, mathematical formula that is given by m lambda is equal to 2 pi r and effective. So for the resonance value, the multiple of this resonance value, the light will go and make multiple more round trips, and n effective is the effective refractive index. Okay, so due to this there is a change in the refractive index because you are giving the light, you are disturbing the free charge carriers, electrons and holes. So that's why there is a change in the refractive index, which is given by n effective is equal to n naught plus n2i. Okay, so due to this n effective will change due to intensity. So if the intensity will change, refractive index value will also change. So suppose when you are giving only the input light, suppose you are giving the input light from the input port, and it will get coupled into the circular waveguide, then you will see there is a transmission graph. Through port will show with the dotted line, and the drop port will show the solid line. So when pump is off, so you will observe there is a resonance value here and here, but when you are giving the pump, so it will get shifted to around 5 nanometer. So this shifting is called optical switching actually. Whenever you are giving high intensity pulse, okay, so it gets shifted either to the right hand side or the left hand side. Okay, so this is called the optical switching because you are giving the light and the output gets switched from one place to another. So as I previously explained in my slide that delta n, you can write the delta n mathematically, that is given by this value delta n e plus delta nh, which is given by the Drun-Lorentz model. So which is given by minus 8.8 and this value. So by this, by you using this value, you can determine the value of the change in the refractive index. And for transfer matrix, or you can say for transmission, you need to solve this equation mathematically, and you will observe the graph. So this is one of the you can say the simulated results. So for this pi phase shift, you need to give 1.82 electron volt. Then you will get the pi phase shift change. So you will see here. So if you want to change the pi shift in this ring resonator, you need to give the power of the pump, which is equal to the 1.82 millivolt. So the polarization, you all know, it is the transformation of the unpolarized light into polarized light, or the restriction of the electric field vector in a particular plane. So this is the basic equations. You all are familiar with this: linear, circular, and elliptical. So based on that, we can derive some modes like transverse magnetic, transverse magnetic, and TEM and HE mode. So as you know, for TE mode, the electric field is purely transverse to the direction of the propagation, and the magnetic field is not purely transverse. So this is the basic things that I have discussed, like photon devices or optical in nature, nonlinear phenomena, it possesses less loss, high compact, easy to be cascaded, easy to be designed as a hybrid device like this. So there are various advantages. So for paper one, I am going to describe one of my paper. So here also, if you are not giving the pump pulse, you are getting the TM mode high, but when you are giving the pump, you will get the TM low. So this is the working of this diagram. So in form of so in form of polarization of light, you can write here that when you are not applying the pump pulse, you are getting the TM, and when you are applying the pump pulse, you are getting the TE. So since there is single waveguide, so we are getting the single transmission curve. So these are the simulated values. So we have done the simulation. After that, after the simulation, we have observed that there is a shift in the 6 nanometer, and we are observing when we are not giving the pump pulse, we are obtaining TM mode, which is like this, and after the pump pulse, we are observing this value. So this is the same result on this MATLAB. So similarly, we have manipulated and stabilized the relationship between the different natures of the light, and we have designed the multiple gates like NOT gate, OR gate, AND gate, like this. So this one I have already described in my previous lecture at this workshop. Yes, polarization rotation in MRR. So this is one of the design of the ring resonator, and we are using a polarization rotation element PR. Okay, so it will rotate the axis of the polarization of the light, which will create the overall rotation. So this is the difference between optical and hybrid circuit. So this is the optical circuit I have explained, and in this hybrid circuit you can see there is electronics as well as optical circuitry. Now, current work, our team is also working on some current work like photonic crystal-based sensors. So for milk sensor, you can see there is a ring resonator, and by using this effect, input light will come. Hello, am I audible?
Yes, sir, you are audible.
Okay. So yes, so this is the temperature sensor. So we have designed this in the FDTD simulation platform, and we have given certain temperatures, different temperatures to design. And due to temperature, there is expansion in the rods and contraction in this rod, and due to this, there is a change in the transmission curve of this device. And based on that, we can conclude that this is the temperature sensor having showing that response like this. Similarly, for milk sensor, by putting the value of the different refractive index of the milk that are available in the website or the literature surveys, we have just observed this result. Similarly, for bacterial water, for different bacteria, we are putting bacterial analyte in this sensing ring, and we have observed this type of result that the work is already published last 2 years ago. Similarly, for cancer cell and all, we have designed uh, different varieties of the sensors as well as optical switches. Recently, my team is working on quantum gates. So it is the recent work, but it is not finished yet. So that's why I am not sharing right now. So if someone is interested to work in our institute, IIIT Bhopal, in my lab, you are always welcome. So the summary of the talk is that the advantages of all optical network over an optical network I have presented. The mathematical analysis and polarization conversion is important to photon absorption, as well as this Kerr effect is important to understand when you are studying the basics of the photonics. So the future work, what you all can do if you are a young researcher, whether you can choose unpolarized light or you can choose the polarized light to design different multi-valued circuits, to design different optical sequential or combinational circuits, to design some rotated polarization dependent circuits, etc. So emerging areas for research, I will invite you to do the research on this quantum technology, because in 2022 the physicists, the three physicists from three different countries got this award for quantum technology, and this is the very emerging topic. So either you can do what is the future of the photonics and all, optoelectronics and all. So you can do research on quantum photonics, neuromorphic computing, uh, AI in photonics, AI ML in photonics, or you can do work on LIDAR technology, Li-Fi and all. So these are the emerging technologies for the photonics. For quantum gates, you can design this poly-X, poly-Y, poly-Z gate using these qubits, hammered gate, phase and control. So if you want to work with my team, so you need to start this work with me also if you have good simulation as well as knowledge of the MATLAB. So these are the references that I have used while preparing this talk. So this is my email ID. So if you have any question, so you can ask from me. Yes, if you have any query, then you can ask.
So first of all, thank you very much, Gaurav sir, for giving the detailed mathematical modeling also you have shown. So it shows your involvement in the research. So really I'm very thankful. Not only that, and you have opened the door for the other researcher also, in what are the areas where people are, if they are interested for collaboration. So I have one question.
Yes, madam.
Yeah, actually, suppose if our student want to
Yes.
do be a
Yes.
project or internship, online internship
Yes.
is there under Prakash Bharti. We are doing
Mm.
online
Yes.
internship. So on this Hadaman Gate,
Mm.
Topoli Gate, Petkin Gate. So we
Mm.
are having this. I worked on this for the quantum dot. Uh,
Okay. Okay.
so, yeah. So in quantum communication or quantum cryptography, I have not worked on that. Okay.
Mm.
So if our students are interested to do the internship from
Mm.
Bangalore,
Mm.
I'm not only talking about my Oxford College as a chair of Prakash Bharti. I'm talking. So
Mm.
suppose from Bangalore based or from IIIT Bangalore section,
Mm.
any of the colleges student are interested to do the online internship. So will you can you able to give the time or evening time or whatever, because starting level you
Yeah.
have to teach them.
Yeah. 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 Okay. Yes, madam. Actually, for do a good job, we need to access one software called Q Interconnect. In Numerical itself, there is one specialized platform for qubits called Q Interconnect. So if someone having the Q Interconnect to any Prakash Bharti member, then it is more suitable, because the it is very difficult to give the qubits in the quantum circuits. Uh, as the software is not like this, but Q Interconnect software is the having the facility to put the qubits as a source as well as detector. So theoretically I can help, but for simulation purpose, this is the challenge that my team is also facing here, because we don't have the Q Interconnect simulation platform. So if someone having the Q Interconnect simulation platform, then we definitely by collaboration we can do some work also.
As per my knowledge, in Indian Institute of Science, ISTEM,
Yes.
I am ISTEM coordinator also for my college,
Yes.
institute representative. So they have COMSOL, LabVIEW, MATLAB, four software are there, which is free of cost. It is accessible to any of the colleges where ISTEM branch is open, like in the sense who are the member of ISTEM. So
Okay.
it is from Government of India. So anybody can
Okay.
be a member of ISTEM college, ISTEM
Okay.
branch.
No problem, ma'am. We will
So
do. I will
they can
personally
take
discuss with
actually
you.
free of
Yeah.
cost.
Oh, okay, okay. So I will discuss personally with you also. I am coming Bangalore by the end of this month or the first week of next month. So I will discuss and we will definitely do some collaboration and work for quantum.
Yeah, very nice. Thank you. So from the participant, anyone is interested to ask any question? So anyone is interested, please tell. Jara sir, please check in the chat.
No, ma'am, nothing. No questions in the chat.
Formal way you can close this.
Yes, one question I have seen. So yes, for actually RI sensor, for RI sensor, for any sensor, because all sensors are almost RI sensor. We are changing the refractive index and getting the value. So for this, you can use any software like RSoft, Opti FTTD, Lumerical FDTD, and all. So any software you can use.
So no more question, Jara sir, in the chat box.
No, ma'am.
Okay. Okay, if no question, then formal way you can end this session.
On behalf of the Oxford College of Engineering and all the participants present here, I extend a heartfelt thanks to Dr. Gaurav Kumar Bharti for the informative talk on recent trends in all optical technology. We are grateful for the knowledge and expertise you have shared in this discussion. We thank you for the time and effort you have dedicated to share your thoughts with us, sir. Thank you once again for the wonderful and informative talk. Thank you.
Thank you, Gaurav sir.
Thank you,
And a
madam. Thank you
special
very
thanks
much.
to you. Special thanks to you. You have given courage to me to conduct this FDP. When I was thinking to start, actually, I was not able to think that how I will arrange so many speakers. Even my principal sir is also very much thankful to you. Everyone
Yeah,
from
yeah,
our
yeah.
college, all HOD faculty, all are very thankful to you. So
Okay.
your session, actually, I informed to principal sir. He is busy in meeting. Otherwise, he was about
Okay.
to join actually.
Okay. Okay.
Okay,
Okay. Okay, madam. Okay.
participant. I will tell you one thing. This is a very good opportunity. Uh, you are getting to collaborate. I will tell you if uh, Gaurav Bharti sir, he is very helpful and very happy to collaborate in any manner. So such type of people you may not get in future. So whenever opportunity is coming, you should speak, you should unmute yourself, and you should talk at least. So we are getting this wonderful opportunity by sitting in our own place and we are able to talk face to face. This opportunity you will never get. And people are very good. They are ready to help in all the ways. So if possible, you take this. So we are not charging anything. We are not asking anything. So this type of opportunity, actually I am taking. I don't know about others, but I always used to take this type of opportunity to make many good things, and and in this way it will be the win-win situation for everyone. Okay, Gaurav sir, thank you once again.
Okay. Thank you, madam.
All,
Thank you. Thank you all.
all the participants, the feedback link is posted in the chat. Please fill that and submit.
What is the